All right, let's read the question now. A local group claims that the police issue more than 60 speeding tickets a day in their area. To prove their point, they randomly select 2 weeks. Their research yields the number of tickets issued for each day. The data are listed below. At alpha equals 1%. Test the group claim, use the p-value. Assume that the population is normally distributed. Remember, guys, if the sample size is less than 30, we have to assume that the population is bell-shaped. Okay, state the null and the alternative hypothesis. Well, look what the claim is. The police issue more than 60 tickets. More than means greater than, like this. Well, if it is greater than, guys, you know it's going to be in the alternative hypothesis. So your claim is in the alternative hypothesis. So you state HA. It's about the mean, not a proportion. You didn't say percent. That's the claim. And HO, guys, is going to be the competing hypothesis. It's this. As I told you guys, if you have a greater in the alternative, you have to have less than or equal to in the null. And this is a t-test. Not a z-test, because you didn't give me sigma population standard deviation, so you're going to just run a t-test. Okay, now let the calculator do the rest. Watch. Go to stat, go to tests, t-test. Even if you make a mistake, guys, and put a z-test, look what happens. And then you use data, because he gave me a data set. You see what the prompt is? It's asking you for sigma. I don't have sigma right there. So that can't be this. Data. Okay, mu 0, you have to put 60. That's the value right here. List, my list is in L1. The frequency, guys, make sure it is at 1. You can never change this one. You change it, you get wrong answers right there. And then greater than, look, the alternative sign is greater than. So this one, guys, is reserved for the alternative sign right here. Make sure to select it. There are times students don't select this properly, and then they end up, you know, just with a different test results. So you make sure to select it. And if you want, we can do a draw just to see. Oh, look at the p-value. It's a huge. That means you're going to fail to reject HO. So T is 0.0597. Is that what everybody got? Let me just make sure I didn't make a mistake with the data. 168, 69, 55, 70. Yeah. So I think that's correct. Double check on your data set just to make sure. So 0.0597 and T, a p-value is 0.4766. Which is bigger than alpha, guys. Alpha is only 1%. So you fail to reject HO. And the conclusion, guys, is going to be exactly the same as the previous one. Your claim is in the alternative. You fail to reject the first one, the HO, that means you cannot support the claim. So you say, there is not enough evidence at the 0.01 level of significance to support the local group claim that the police issues more than 60 tickets per day. That means their claim is not valid. They're making a wrong claim about the police department. Any questions, guys, about this question? All right. A local brewery distributes beer in barrels labeled 32 ounces. A government agency thinks that the brewery is cheating its customers. The agency selects 26 of these bottles. So N is 26, guys. Measure their contents and obtain a sample mean X bar of 31.45 ounces. And a standard deviation, he didn't say population standard deviation, so it's S, guys, 0.65 ounces. Use an alpha 5% significance level, 0.05, to test the agency claim that the brewery is cheating its customers. So the bottle has to have 32 ounces. If the government agency thinks that they're cheating, what does that mean, guys?
There's less than that many ounces?
Exactly. I didn't say it explicitly in this question, but cheating means you're getting less than what you should be getting. That's exactly what it means. So look, mean is less than 32 ounces, and that's the claim, guys. Not by the brewery itself, it's by the government agency. Now, again, if you ask me why did I label this as HA, because the less than must be HA. And now HO will be the competing hypothesis. I mean, I could have rewritten this one and said to test the claim that the mean contents of beer in the bottle is less than 32. But cheating, guys, means the same thing. Okay, this is a t-test. See how important the t-test is. Very, very important test. Okay, let's do it. So you go to stat, tests, t-test. Not data here. I don't have a summary. I don't have the raw data. I have a summary. So just go to stats again. Okay. U0 is 32. We take this value from the null. X bar is 31.45. And you continue. S is 0.65. N is 26. And make sure to select the proper sign. You see, guys, greater is selected. That would be wrong if you keep it there. You have to go to this and press enter. And try it with me, guys, so you know that you can do it when we're offline. And if you want, I can do a draw. So T is negative 4.3146. Oh, 3146, negative 4.3146. And the p-value, guys, let me write it down and explain to you what that means. You cannot write this as an answer because that's a calculator interpretation. E minus 4 means move the decimal point 4 digits to the left. Here's a decimal point. To move it 4 digits, guys, you have to add 3 more zeros because I don't have enough. So this is actually that. I'll give you a hint, guys. Once you see an E as an answer, the p-value is almost 0. It's less than alpha for sure. It's going to be very, very small. P-value low, HO must go. So this is less than alpha. Decide to reject or fail to reject the null hypothesis, definitely reject. HO. Okay, would the students give me the conclusion here? We rejected this guy and the claim is in the other one. So what do we say? There is enough. Some books say sufficient evidence. I think this book says enough evidence at the 0.05 level of significance. To what, guys?
Support.
Support the claim, yeah. Once you reject HO, guys, and the claim is in HA, you support the claim. That means your claim is good. To support the claim, by the government agency, that the brewery is cheating its customers. That's a very serious claim, but but it's valid now. That means the brewery is in trouble here in this case. That's how they do that. Okay, so that's number 3. Let's go to number 4. It's a proportion now. According to official census figures, 80% of couples living together are not married. A researcher took a random sample of 400, that's N, and found that 39 of them, that's X, are not married. Test at the 5% level of significance, that's alpha. If the current percentage of unmarried couples is different from 80%. That's the claim, guys. So HO, HA. Do you guys agree with me that I have to use a P here? It's a proportion. And would a student tell me what the null and the alternative would be in here? Any input here would be appreciated. What do you guys think the signs are going to be?
Is it not equal to 8%?
Yeah, equal or not equal. So not equal, the 8% is right here. And equal right there. You have to figure this out, guys. As you notice, when I first started this chapter, I spent over almost a couple hours just showing you how to state the null and the alternative. That's very, very important, guys. And different from means not equal. And you know these come together. So if there is not equal here, then you must have equal there. And my claim happened to be here. And this is one prop C test. Okay. Let's do it. Stat. Tests. Okay, 0.05 08. Don't put it, you have to change it to a decimal. X, guys, is 39 out of 400. And look, I'm choosing not equal here. Okay, guys, calculate. And here's Z, and here's the p-value. So Z is 1.29. P-value is, it's big, so you're gonna fail to reject HO, 1970, which is bigger than alpha 0.05. Fail to reject HO. And would someone volunteer to give me the conclusion here?
There's not enough evidence.
At the 0.05 level of significance. Can you continue, please? To
Support.
the claim. Yeah. Exactly. When you say the word support, it doesn't mean you're supporting. You're saying there is not enough evidence to support. So you're saying I'm not supporting here, but you have to use the word support in here to support the claim that the current percentage of unmarried. I'll just copy it and paste it. Couples is different from 8%. All right. So that's question 4. Okay, let's go to another one. Five. A sample of 1,600 items produced on a new machine showed that 97 of them are defective. So you guys can tell that the big number is going to be N. When there is no mention to a mean and standard deviation, you know this is a proportion, and that's X. The factory will get rid of the machine. Oh, I should have all there. Of the machine if the data indicates that the proportion of defective items is significantly more than 5%. At the significance level of 5%, does the factory get rid of the machine or not? So they will get rid of the machine. They say the machine is no longer good if the proportion of defective items is more than 5%. So would you guys agree with me? If I say P is more than 5%, that's the claim. We want to see if this is the case. If the proportion of defective items is more than 5%, they need to replace the machine. Well, let's check if they need to replace it or not. We run a hypothesis test. So you guys agree with me that if you have a greater than, it should be a less than or equal to here. And that's 0.05. Okay, it's one prop C test. Let's do it together. 0.05. 97. How many do we have? I think 1,600. And guys, look, I'm gonna choose the proper sign here. So Z is 1.95. And p-value is 0.0256. Let's compare it with alpha. Alpha is 5%, guys. This is less than alpha. So we reject HO. There is enough evidence at the 0.05 level of significance to support the claim that the proportion of defective items is more than 5%. Now, here's my question to you guys. Should the company get rid of the machine? Yes or no? Or does the factory get rid of the machine? We say there is enough evidence at the 0.05 level of significance to support the claim that the proportion of defective items is more than 5%. So will the company the factory get rid of the machine?
Yes.
Yes, definitely. Because if the proportion is more than 5%, then they said they would replace the machine. Well, we say our test indicates that it is the case.
Mr. Bazzi,
Mm-hmm.
I'm not sure if I'm missing something, but I'm a bit confused. How is 0.256? How is that more?
Oh, it's not 0.256, 0.256. Here's how I compared it. Watch. Here's how you compare. Put this and put that right there. Start. 0 is the same as 0. Dot, dot. 0 is the same as 0. Now go to the second digit now after the decimal. That's a 2. And the second one, that's a 5. 2 is less than 5. You just put that.
Okay. Thank you.
Make sense?
Yes.
Yeah, that's how you do it. Compare them digit by digit. All right, so p-value, that's, so the company should get rid of the machine. The factory should get rid of the machine. Now you can see how hypothesis testing is used to make decisions in business. Okay. Let's go to number 6. I'm gonna give you a good feel about this chapter, guys, through those exercises. An expensive restaurant claims that the average waiting time for dinner is approximately 60 minutes. But we suspect that this claim is inflated to make the restaurant appear more exclusive and successful. You know, when you hear about a wait time at a restaurant, it's too much time, you think that the restaurant is a big deal. And that's probably an impression that they're trying to make. A random sample of 32 customers, so N is 32. Yielded a sample average waiting time of 50 minutes, so X bar. the population standard deviation for waiting time to be seated at a restaurant is known to be 10 minutes. Who can tell me what the sample for this one is going to be?
Sigma.
Yep, thank you. So now, guys, here's a hint for you. It's going to be a z-test. Because he gave me sigma. All right. Is there an evidence to say that the restaurant's claim is too high? So we think that they're inflating their time figures. We don't think it is correct. How would you state the claim? Okay, I'll just give you a hint. They're saying it's 60 minutes. We don't think it is. What would go here, guys?
Less than.
Less than 60, exactly. That's what we think. We're not studying their claim. We're studying our claim that we think that this number is inflated. And that's how you proceed. Okay, z-test. Again, if students have a question why we're using z-test, we are using z-test simply because he mentioned population standard deviation. Once he mentions that, you are doing, a normal, standard normal distribution z-test. Okay, let's do this, guys. Stat. First test. Mu 0, you put 60. Sigma 10. X bar is 50. N is 32 restaurants. 32 wait times. And less than. Okay, Z is negative 5.6566, negative 5.66, and p-value is 0. It's very small. Well, definitely this is less than alpha. And reject HO. That means there is enough evidence that the restaurant claim is too high. We're going to support our claim. There is enough evidence. At the 0.05. Oh, it didn't give me alpha, but I'll use 5%. At the 0.05 level of, it doesn't matter what alpha is, guys. The p-value is 0. So no matter what alpha you put here is 0, it's going to be less than that. The level of significance to support the claim that the restaurant's time is inflated. All right. The original data individual waiting time is not normally distributed. How could we do this problem? What theorem allows us to do the calculation in part A? Because the sample size is more than 30, guys. It doesn't matter whether the original population is normal or not. Look, that's 32, so we're safe. It's a central limit theorem that allows us to do that. This is what you did in section 5.4. Central limit theorem. All right. Any questions about number 6, guys? Okay, we're gonna go to the next one. 7. All right. In a survey of 1,273 adults, 668 said it's not morally wrong to change the genetic makeup of a human cells. Can you support the claim that majority of adults do not think it's morally wrong to change the genetic makeup of a human cells? Use a level of significance of 10%. So this is alpha, this is n, this is x, and I would like a student to tell me what HO and HA are going to be. He says, can you support the claim that majority, what did we say majority means, guys? We discussed that in class on Monday. What does majority mean? It's a proportion, percent. So put P, what would it be, guys? If someone has majority, means has more than what? 50%.
50%.
Exactly. You know, we had elections last night, and anyone who got over 50% was declared a winner, regardless of what type of race they were running for. So that's what it means. And if I give you the same question, guys, on a test, and I said, can you support the claim that minority of adults, you make it less than 50%? So if this is a greater, guys, you agree with me that this one has to be less than or equal to. Remember again, guys, these two must be always together. These two must be always together. And these two must be always together. In any question, guys, you must have either these two. This is HO, and that's HA. Don't change that one. When you do your homework online, they might confuse you. And they put the greater than in HO and this one in HA. You don't select that one. That's wrong. Even if you have to select these two, but this one must be in HO and that one here must be in HA. Okay, it's one prop C test, guys. Okay, let's do that. Okay, guys, be careful. This is 0.05, so I need to put 0.5. X is 668. N is 1273. And check here, make sure I need a greater than. Look, guys, so you do this. See, if you don't press enter, you're not there. It's still in the middle. So you have to press enter. Now it's working. Let me change the green to navy is good. This is a right tail test, so the p-value is going to be on the right. There you go. So Z is 1.77 and the p-value is 0.0387. show you again. 0387, which is less than 10%. So we reject HO. There is, if you reject HO, you start with there is enough evidence at the 10% level of significance to support the claim. Maybe you wonder, I haven't used the word reject because all the questions we did today, the claim happened to be in HA. I'll make sure to do a question where the claim is in HO. So I show you what to use here. There is enough evidence at the 10% level of significance to support the claim that majority of adults. Just copy it and paste it, guys. Just copy and paste. Majority of adults do not think it's morally wrong to change the genetic makeup of a human cells. Do not think it is morally wrong to change the genetic makeup of a human cells. All right. So we did quite a bit about the proportion. We have one more, and then I'll give you a break after this. It was found that 821 crashes of mid-sized cars equipped with airbags, 46 of the crashes resulted in hospitalization of the drivers. Using the 0.01 significance level, test the claim that the airbag hospitalization is lower than the 7.8% rates for cars with automatic safety. So guys, lower, can we agree, guys, that lower means less than? Again, all the questions we did today, the claim turned out to be in the alternative. So P, don't put mean, that will be wrong if you put mu here, the sign. It's just you have to put P, less than 7.8%. And that would be P. Put the column right there. You have to put a column there, 7.8%. And that's the claim. Okay, I have N is 821. X is 46. And alpha 0.01. Okay, let's run the test. I meant to do as many exercises as possible on the proportion test. That's a very important test, guys. Okay, 7.8%. First of all, you have to change this to a decimal. So 7.8%, guys, is 0.078. Let me just write it down here. .078. X .46. N is 821. And choose the proper sign, which is less than. So Z, guys, is negative 2.35. I'm just gonna put the steps, what we did here. X is 46. N is 821. And we selected the less than. So we get Z is -2.35. P-value that's very low, guys. So that's less than alpha, of course. Alpha is 0.01. And again, here's how I compare, guys. 0, 0, they're the same. Dot, dot. 0, 0, they're the same. Now, second digit is 0. This one is 1. Well, 0 is less than 1, so you can stop. It's less than. We reject HO. There is enough evidence at the 0.01 level of significance to support. You reject HO and the claim is in HA, guys, to support the claim that airbag hospitalization rate. I'm just gonna write it down. Is lower than 7.8% for cars with automatic safety. There you go. So that conclude this. And now, guys, you should, this is a summary on how to use the calculator for each of the tests. If you need help, you forget how to use the calculator, I put, a summary for each section. So make sure to reference to this one. So that concludes section 7.1 to 7.4.